Lesson 10-7, Area of Circles and Sectors. The area of a circle is pi r squared. The following question says, what is the area of a circular region on the wrestling mat? Our formula is pi r squared. We're given the diameter at 32 feet. That gives us a radius of 16. So our formula becomes pi times 16 squared. That gives us an answer of 256 pi, which is approximately 804.25 feet. The next thing I'll talk about is the sector of a circle. It is a region bounded by an arc of a circle and two radii. So the shaded section on the circle is called a sector. So our formula is what fraction of the circle is covered times pi r squared. So you need to figure out what's the measure of the arc and what's your radius. This is what your questions will look like in your homework. What is the area of the sector? GPH. Leave your answer in terms of pi. So what fraction of the circle is covered? 72 out of 360. Then we look for our radius, which is given at 15. So we calculate 72 out of 36 times 15 squared, leave it in terms of pi for 45 pi. Number 2 does not have a picture. A circle has a radius of 4. What is the area of a sector bounded by a 45-degree minor arc? Leave your answer in terms of pi. This is what our scenario would look like. So we want to know what fraction of the circle do we have covered. 45 out of 360, and our radius is 4. This simplifies to 2 pi. The last thing we'll talk about today is the segment of a circle. It is a part of a circle bounded by an arc and the segment joining its two endpoints. So to do this, we're going to first find the area of the sector. Then we're going to subtract out the area of the triangle, and that will give us the area of the segment. So let's try one. We need to find the area of the sector. So this will find everything that's green. So we have 90 out of 360 degrees times pi times 4r squared, which simplifies to 4 pi. Next, we're going to find the area of the triangle, shaded in pink. Both sides of the triangle are the radius of the circle, so it's a 4 by 4. Area of a triangle is 1/2 base times height. So we get 1/2 times 4 times 4, which equals 8 pi. So we have 4 pi minus the area of the triangle, which is 8, and that's going to give us the shaded of the yellow. Rounding to the nearest tenth, we get 4.6. Next question is the same idea. Find the area of the entire sector. So that's 60 degrees out of an entire 360. Radius is 18 squared. That simplifies to 54 pi. Next, we have to find the area of a triangle. So here's a trick. The area for an equilateral triangle is 1/4 square root of 3 times side squared. This is a 60-degree angle. The radius and the radius are the same, so it's isosceles, which makes these base angles both 60. So we can use this formula. So if I plug in 18, the area of my triangle is 81 roots of 3. On our calculators, 54 pi minus 81 roots of 3 is approximately 29.4. Try these two problems. Pause the video till you're ready to see the answers. So on the first question, we're just finding the area of the sector. So we have 75 out of 360 degrees times the area of the circle, 9 squared pi. Rounding to the nearest tenth, we get approximately 53 square inches. The next question takes a little more work. We need to find the area of the sector, 120 out of 360 times the area of the circle. Then we're going to subtract out the area of the triangle. So I redrew that triangle looking at 1/2 base times height. It is isosceles, which means there's 60 left over for those two angles, which gives me 30 here and 30 here. So I redrew the picture down below. 2 is given. Using my special right triangles, hypotenuse to shorter leg, the 2 becomes a 1. Short leg to long leg, 1 becomes root of 3. So if this is root of 3 and this is root of 3, I really get 2 roots of 3 for the base. And then the height was given down here as 1. So half of 2 is 1, so we're left with the root of 3 for the area of this triangle. So when we subtract to the nearest tenth, we get 2.5. This concludes my lesson.